My name is Corbin Church, and I am the CEO of Cambridge Touch Technologies. And I'm here to talk to you today about our technology, which we call UltraTouch, which is for any smart device, not just smartphones, but in the auto or anywhere where you find a touch screen. And our our mission is not as manufacturers, but we develop the key technologies that are then adopted by our customers, who are the OEMs and their supply chain. We've been around since 2011. University of Cambridge spin out. This is why we're located in Cambridge. Our CTO is actually an ex-prof there. We've got a great set of investors as well, including China Materiality. And a number of patents, which is growing very quickly. A small but very motivated and dedicated team, very technically capable, lots of PhDs. And our markets are not just in the consumer markets, but also auto, industrial, and military as well. So if I look at the smartphone market, the last few years you may have known that the smartphones, they all start to look very similar to one another. It's a huge market, but the competition is also very fierce. And a number of big companies have tried new things, especially in the UI and UX area, because that's a very consumer or user-focused aspect of the phone. And we've seen numbers of different technologies, 3D touch being from Apple, maybe the most well-known. Like folks like Huawei, Google, even Sony have tried some new ideas as well. And since 2015, we're already seeing many devices in the market, almost 1 billion of them, with these enhanced touch approaches or UIs. But if you really look at it and take a step back, when you compare it to the overall market size, this is still a drop in the bucket. So it's quite constrained still, and there's a couple of reasons for that. Existing technologies that these other folks are trying right now is very difficult to scale beyond smartphone size. They're quite complex to manufacture as well, and that complexity leads to high costs, which is limiting the adoption. And all of the incumbent technologies are non-transparent, and you'll see in a second where they put their sensors below the display, which is a very difficult and bad place to put a sensitive sensor. So, and we're also seeing, these new concepts starting to come to market, and we just saw with the other speaker, Royale, which is amazing to see with their new foldable phone, apparently. So I look forward to seeing that. But we're seeing a lot of these foldable phones and other applications that are starting to emerge and penetrate the automotive world as well. So we're going to see a lot of new displays and a lot of new form factors that are coming to market. So that really puts a lot of pressure on the UI for going forward in the touch technology in particular. And we see, for it to really capture these new markets and these new device ideas and structures, you really have to have a number of specific aspects. You need to have all of these types of aspects, not just some of them, which is what the problem is today with the existing or incumbent technologies that are trying these new enhanced UIs. So you really need it to be, a fully integrated solid state. You need it to be flexible, because these phones are going flexible, and all their curves in the cars and things like that. Transparency is very important. Of course, low cost needs to be much more cost competitive than the existing technologies. And it also needs to scale to any size. Right now, it's really limited to one form factor size right now, which is a smartphone. We need to get beyond that to anything. And it has to fit all applications, so not just smartphones. There's also tablets, the auto, anywhere where you find a touch screen. So our technology we call UltraTouch. We consider this as a next generation technology, which really does address all of those requirements that I just listed in the previous slide. And from a concept point of view, it's actually quite simple. We're using a new highly functional film where, see the PET on the left-hand side. This is a very standard stack up on the left-hand side. Literally billions of devices are made this way currently. And what we're doing is taking this new material, this piezoelectric material, and replacing the PET, the existing PET, with this new high-value material in there. And so to manufacture it like this, it's the same manufacturing process and steps, and so it's highly manufacturable and easy for the existing supply chain to adopt this kind of structure. And with that, you can get some additional, not only the usual X and Y location capability, but you can also get Z or Z in terms of force sensing as well for all fingers. And just to give you an example of how this works, so this is a 12.3-inch display we did for auto. This is an auto GUI, so you can do slide and press, so it won't activate the music until you push it. So that's replacing mechanical buttons. And so you can see that we have very good linearity in terms of being able to press into the screen, not only just for one finger, but for multiple fingers as well. And, a few people have shown that. And this is brand new, so you can actually do this underwater as well. So this is an app, a camera app, where you can actually take photos, do pinch and zoom in underwater as well, and actually use your device. All these phones are going, the big marketing push is that these phones are water resistant. Well, the next obvious thing is to be able to use them underwater as well. So we think this is going to be a new kind of experience that will really ignite the consumers, especially the younger generation of consumers. Of course, in the car as well, we find lots of potential applications for this technology in the car, and so do our customers. So, as I mentioned, we use this piezoelectric film, this new highly functional film in this market. This is the materials aspect of our technology. And it has a lot of big advantages, one being that it's optically transparent, which is very important. So that lets you put it above the display, not below the display. When you put it above the display, much easier to manufacture. Because it's also a film, much easier to make it in any size of display or of touch panel, not just for smartphones. It's got the same feather touch for capacitance. So add the force sensing from the piezo signal as well, saves the power. And also less for the consumer, but more for the manufacturer, fully integrated. This is an all-in-one type of technology, so it's very robust mechanically. And that all leads to high yields and at the end of the day, lower costs, which is the number one issue. And if you compare it to PET film, which is what is the standard out there, it has very similar, sometimes even better parameters than PET. The materials is the one very important aspect. The other very important aspect in our technology is the algorithms that we have developed in order to make the material behave properly. So you want the material to naturally react the way that a consumer on a phone would expect it to react. That sounds a lot easier than it is. So the algorithms are extremely important, and we have some AI in there as well. So the algos and the AI combined with the materials are what really enable the entire UltraTouch solution. And I should say, here I've mentioned that there are a couple of different types of ways to integrate touch into a display. External is a common one, like I show on this graphic. But on-cell and in-cell, if you know the market, are also increasing very rapidly, especially in smartphones. So this is also compatible to those markets as well, including foldable. And I'll also mention that we're agnostic to the type of transparent conductor. So we've seen some great talks from folks who are talking about silver nanowire. So this will absolutely and is used with silver nanowire as well. We've been very busy on creating a really, I think, a high-powered ecosystem of tier one partners to really enable this market, to bring it to the OEMs and their customers. So we've been working very closely with those who actually build the piezo film suppliers, the Touch IC market, Touch IC providers as well. makers, and then also those who are actually building the touch panel, whether they're the external touch panel makers or the display makers who then incorporate touch into their displays. We work with both of them. And we're working, as I say, with some pretty high-powered folks. Two that are publicly announced are Solomon Sistek on the Touch IC side, and then also Futaba on the touch panel side. Futaba is, both of these folks are leaders in their categories. So just to wrap it up, with our Ultra Touch technology, we see this, very this enabling the next generation of devices. This all because of this new highly functional material, piezoelectric material, which along with our algorithms make the technology possible. The big advantages here compared to incumbent technologies are that it's fully integrated. It's this all-in-one technology or a structure, which is quite easy to manufacture, and that reduces the cost significantly compared to what the incumbent technologies are today, and really does enable these new ideas and these new form factors, which will grow the market beyond to where it is today. That's all I have. Thank you.